Welcome to Try It 6. We're going to continue our exploration of continuous outcome data. This time we're going to be focusing on splitting our data into groups and making comparisons between groups. We'll be looking at splitting data into groups on one predictive variable or on more than one predictive variable, and then comparing outcome scores. And we'll look at decision rules of when do we decide if two groups are really different or if they're just the same and any difference is just chance variation. We're going to use the data set that we've been using on the Academy Awards. We're going to add a couple of extra variables. So the variables we're going to be looking at today are gender and age at award, like we've done before. But we're going to add in a couple of other potential predictor variables. We're going to add in hair color. We're going to add in the decade, whether it was one in the 1930s or the 1970s or the 2010s. So we're going to be able to ask questions like, I wonder if the different genders won awards at different ages. Is there a different average age between those two genders? We can ask, has that pattern of gender and age at award changed over the decades, or has it remained stable over the decades? We can then complicate things a lot and ask, is there a pattern of data between the genders and hair color and their age at award? Let's start with the simple ones. Well, let's start with going and getting the data. We're going to continue to build on the work we've already done by examining the population of the Academy Award Best Actor and Best Actresses. You've got the link to the Google Doc. And here's the data. I'm going to select that and copy it and come to Excel to paste it. I'm going to paste that in a new blank worksheet in Excel. I'm going to practice my good habit and preserve the raw data. Labeling that first sheet raw data, inserting a sheet, doing Control-V to paste again, and double-clicking to call this one visualization. Let's start by splitting the data by gender. I want to know, do men and women win the Academy Award at the same age or at different ages? So what is our predictor variable in this case? And is it measured categorically or continuously? What are the levels of it or the scale? And how about the outcome variable? What's the outcome variable we're considering? And is that measured categorically or continuously? And what's the levels or the scale? Remember, categorical variables are labels, they're words, they're groups. Continuous variables are numbers, they're along a continuum. So if you've got a categorical variable, it's going to have levels, and those are going to be the group labels. If you've got a continuous variable, you're going to have a scale where you'll be telling me that it's in inches or in days or in years. Let's start by splitting the data into two groups based on gender. So one group for the females and one group for the males. And then load the data into SEEIT so that we can visually compare those distributions. What we need to do is copy the two different groups into different columns. That doesn't make much sense from a data management point of view. The outcome variable should be in the same column regardless of which group the person is in. So for example, this female has the outcome age in years and this male has the outcome age in years. And this is the correct way of managing this data. But in order to load it into SEEIT, we need to split the data into the two groups before we load it. So we're going to sort by gender and then load the data into SEEIT. I'm going to highlight all of my data and I'm going to come under my data pull down menu and choose sort. My list has a header row. I want to sort by gender. And click OK. Now I'm going to grab my outcome variable for all the females. So I'm just going to highlight, click and drag, and highlight all the female ages. And I'm going to copy that. I'm going to jump to a new sheet to paste it. And I'm going to paste it starting in cell A2, because in cell A1, I'm going to type the word actresses. These are the best actresses. I'm now going to go back and get the ages for the best actors. So I'm scrolling down until I start seeing the men's ages, and then clicking and dragging and selecting those. Copy, jump to sheet 3, starting in B2, paste, and these are the actors. This is my entire population. We won't often have the luxury of having an entire population. So we're going to start practicing by taking a sample of this and practicing the reasoning that we'll need in order to get from the sample to the population. I want to be able to randomly select 25 of the actresses and 25 of the actors. In order to take a random sample, I'm going to add in a random number, a column of random numbers. I want to make sure that I don't make the mistake of sticking the actors and the actresses together, that I want to select the actresses and then select the actors. Let me make that really clear. I'm going to go ahead and insert a column between the actresses and the actors, just so that I don't make the mistake of thinking that the actress in cell A2 belongs with the actor in row 2. So let me put my random numbers in here. Do you remember how to have Excel generate random numbers? I can click on that f of x to insert a function and search for random. And I just want a random between 0 and 1. And I'm going to insert that function. And there's the random number that Excel has created. I want to fill that down. So I'm going to scroll down to the bottom of the list. And I'm going to use my other hand and hold down the Shift key and single click on the last cell where I want the random numbers filled. So I've selected the whole block, starting with the formula. And I'm going to come up to my Edit pull-down menu and choose Edit, Fill Down. I could also obviously have just clicked and dragged on the bottom right corner. So let me select 25 actresses. I'm going to click and drag just over cell rows A and B and choose for my data pull-down menu, choose Sort. And I'm going to sort by that random number. I'm going to select the first 25 of them and copy those over. Let me just paste them in column E. So that's my random selection of actresses. Let me repeat the same thing and select 25 actors to be in my sample. I'm going to use the same column of random numbers. So I'm just going to select B and C and data sort by random, OK. And I'm going to choose the first 25 actors. I've selected a random sample of 25 of the actresses and 25 of the actors. I'm now going to be able to go and compare these distributions. I'm going to highlight my sample and copy it. And then I'm going to jump to See It. And down at the bottom, I'm going to choose to add a data set. I'm going to Control V to paste. So I've got my actresses and my actors. Let's call this Age at Award by gender. The first column is not a label, the first column is data, and load it. Okay. And we come down and we see that it's been added to the list of data sets. Let's practice our visual reasoning skills. Let's compare those two distributions. I'm going to grab the actresses data and drop those onto a graph. I'm going to add another graph, so I'm going to click on that hot button New Graph. I'm going to grab the actors and drag them down there. See it put them on the same scale? Does that make direct comparison possible? Let's look at the descriptive statistics. I'm going to click into advanced mode, click the wrench, and let's look at the box plot with the standard deviation, and let's add the mean and apply to all. If the mean didn't display the actual value, you can click on those red squares in order to display that actual value. So these are the samples that I took. Yours would be different, but they should be pretty similar. I ended up with a 9-year difference between my samples, where the actresses on average were winning the Academy Award for Best Actress at 37.3 years old, and the actors, the males, are winning it at 46.3 years. And that if I look at the clustering of the data, they look like very different patterns. What was the difference in means in your sample?